Okay, Olivia, you asked about two problems, number 7 and number 8. Let me go over both of those for you. Number 7, we're solving both of these equations on this interval from 0 to 2 pi, so on one trip around the unit circle. So for this first one, number 7, notice that the equation already has the tangent of this stuff in the parentheses isolated equal to 1. So we can go ahead right away and inverse tangent both sides of the equation. When we inverse tangent the left side, we end up with this left side, theta over 2 plus pi over 3. And then when we inverse tangent the right side, we're looking for the angles whose tangent is 1. Well, that would be pi over 4. Pi over 4 has a tangent of 1, a y value divided by the x value on the unit circle, and also 5 pi over 4. So we get these two branches of the equation, two solutions. Now this plus 2 pi n is not really necessary in this problem, and it just serves to confuse things. So I think you should ignore this plus 2 pi n and just think about the pi over 4. Then we're going to solve for theta. So that means we're going to subtract pi over 3 from both sides, and then we're going to multiply both sides by this 2. And when you do, ignoring the 2 pi n and ignoring this plus 4 pi n, you get theta equals negative pi over 6. That's one possible solution. Over here in this branch, over here on the right side of the squiggle, the same steps to the 5 pi over 4, which is another angle whose tangent is 1, an angle whose y value divided by x on the unit circle equals 1. Then we subtract pi over 3, multiply by 2, and you get 11 pi over 6. Again, ignore this 2 pi n and this 4 pi n. They're not relevant. Now, 11 pi over 6 is in the interval from 0 to 2 pi, but negative pi over 6 is not. So we throw negative pi over 6 out as a solution because it's not in the proper interval. And that's it for that solving. Over here on number 8, it's a little simpler. We're looking to solve this. So first thing we're going to do is isolate cotangent of theta by subtracting 1 from both sides, and then dividing both sides by the square root of 3. Here we have that part of the problem. And then we're looking for angles whose cotangent is equal to negative square root of 3 over 3. Notice this negative square root of 3 over 3 is the same as this negative 1 over square root of 3, just rationalized. The denominator has been rationalized. Now, we're usually not accustomed to finding cotangent on the unit circle. We're more comfortable with tangent. So if we just reciprocal both sides, the reciprocal of cotangent is tangent. The reciprocal of this fraction is negative square root of 3. So then we're looking for angles whose tangent is negative square root of 3. Again, tangent on the unit circle is the y divided by the x. So those two angles would be 2 pi over 3 and 5 pi over 3. Okay, so I hope that's helpful for number 7 and number 8. Over here, I've got some things to consider for you as you study for the open-ended exam. So you can read through these things, and I hope they're helpful ideas for you as well. Okay, that's it. Thanks.